I am a postgraduate student at Politecnico di Torino. While studying course of computer architecture, we were assigned a project to develop a game on NAND Tiger board that contains a microcontroller and with its peripherals. So the peripherals that we were supposed to use for this game were GLCD and potentiometer. Using these two, we have developed this game. Now we will give a demo here how the code works and how its graphical effects are changed based on this code.
Hi guys, I am Malik. I am project member of Tahir, and now we are going to show you a bit about our code, and we will show you how to run this game. But before going this, we developed another video. If you follow our link below, we will provide the links for both the videos, or you can just simply search Land Tiger board game right arm and you will find the first video. We will just play the part of our video where we explain in this part the game we developed, the same game but without using any interrupts. Okay, we were used polling to get the signal to get the data from ADC, and we also used polling to display on the screen. I'm just going to play it and just see here the resolution a bit. You can see a lot of flickering here. It takes, like, for visibility is not so good. Then we developed a newer version of this game. We used interrupts for this. So before showing the video, let's just look at the main files of the code, and then we will start the game from the code. As you can see here, you can read the description. Okay, these are the add-ons file viewing of GLCD of ADCT. We use static timer to generate interrupts. Here we define a global variable, fix a prescaler to this value, just for using a timer 0, just for giving a delay initially to display some data. These are header files, prototypes for reading data from ADC to generate the patterns of the game. And these are our global variables, we define them, and this is our main interrupt service routine. Before going to interrupt service routine, I will show you our main code. We initialize the static timer and pass this as an interrupt service routine whenever interrupt occurs, so it will jump to this interrupt service routine. We initialize our system, we set up the core clock, we initialize our GLCD function. If you want to see any function, just right click on it and go to the definition of this function, and from here you can see, because we used libraries for them. Then we clear the LCD with red color, we initialize our ADC, we initialize our timer, and then we display the text how to play this game and things like this. Here we will start our static timer. So if we go to static timer definition, it generates interrupts by that many clock ticks divided by 2. If we see the value of that clock ticks, I set it to, let me go here. Okay, I set it to this, which means 10 milliseconds. So I am dividing it by 2 to generate interrupt after every 5 milliseconds. So okay, then as soon as it starts, this is in the while loop, it just counts unit place and 10 place values. This is our timer function, we initialize it here, and this is just a simple function we use to give millisecond delays as you want. Okay, this is a function where we read our ADC. We initialize some buffers, we take 8 data just to filter them out, and then take their average, and then convert it to our required conversion, and then scale for data to be observed in our screen. Okay, before going forward, let me come to my interrupt service routine, and let's open the board.
This is the demo of the game. When it starts, it introduces the project and our name as developers. Then this game just starts from its starting point. Here there are some obstacles that are moving from top to down, and we are having a shape of car that is trying to avoid from these coming blocks. Position of this car is adjusted by rotating the potentiometer. While rotate one side, it moves from one side, and when we rotate to other side, car moves towards the other side. There are three types of patterns that are moving down in the form of obstacles. So you can see this is one pattern, this is the second pattern, and the other pattern is the one that moves when these blocks are in the center. This is the third pattern. When we collide, we are just game finishes and the score is reported how many blocks you have successfully. Like here we are having score of 0 2. This is the score, these are the total number of blocks that we have escaped. So this is the basic variant of the game. Now we will see that how this game is linked with its code. What is the meaning of this blocks, how this car is managed, how these blocks are managed, and how score is counted. So now Waleed will explain you how these blocks are linked with the code.
Sorry guys. So this is our while loop. So let me go back to my interrupt service routine. So after each 5 milliseconds, it generates an interrupt. So when it generates the first interrupt after 5 milliseconds, initially I have initialized this counting variable to 0. Initially it's 0, so it comes here, and at the first interrupt, it just reaches the web position of the ADC, okay, and increments counting by 1. Then after 5 milliseconds, when the next interrupt generates, it comes here and run these else conditions, and it initializes counting to 0. Initially the value of enter is 0, so it generates the first pattern. It goes to the inside this function, and as if you can see, there are 240 by 320, or sorry, 260 by 340 pixels here. So okay, if I show you, when the below one reaches this limit, so it means generate the patterns till it from top to the below. It's just doing this, and increment by 2 to show the smoothness. You can change this value based on how big a jump or how fast you want to go down. And then if it comes to the last pattern here, then it just increments your value when it is avoided. Let me go to the first init function. This value, these are the two functions of the library we are using to generate the rectangles. And then to generate next rectangle, you should remove the previous one so the user cannot see it. Just say going it down. These are the two functions just to display our score. Then we use these three rectangles to create our shape of the car, which you see there. You can move this position anywhere you like. You can change the height of the car, you can change the height of the boxes. And here we are checking the collision, because in the first pattern, if you can see, let me go again. In the first pattern, I have to avoid from this and this from both sides. So that's why I am checking the position. If its pixel is less than here, it will display the score and show it you have lost and initialize our values again. And similarly the position from now. We can go back to our machine for the second pattern. And this is the second pattern. For this pattern, you should be on the left position. So again, these are the same thing, just the checking of position is checked here. If it's greater than this, it means it will be in this limit. And similarly, we can go to the third pattern, which let me I lost. This is my first pattern. This is my second. Now this is the third pattern generation. So to avoid this, I should be on the other side as before. You can change the values and play with them and generate your own patterns. Another thing which I want to tell you, each time when it strikes, I stop the static timer, because otherwise it will keep generating it every 5 milliseconds. So we stop it here, we display the message and give it a delay for, let's say, 4 seconds for the user to read. You can change this also as you like. Then clear the screen, can initialize the variables again and start the static timer again. So this is the main scheme we are using. This is our interrupt service written here. Other things, libraries, they are well commented. Even you can read this. You can find the link of all the compiled project in the GitHub below. and I will just play a little bit game for you guys to show while my colleague like to sub comments.
So this game is basically a learning variant for using LCD and potentiometer. What potentiometer does is it uses an ADC. ADC reads the analog voltages across the potentiometer, converts them into a digital value and sends them to the microcontroller. Microcontroller based on that value adjust the position of this small shape of car, and the blocks they are coming, they keeps on coming based on the 5 millisecond static timer that we are using. Main purpose of this project is the learning relevant to this land tiger board, and more specifically focusing on two peripherals. One is its GLCD, that is graphical LCD, and the other one is its ADC, that is directly linked with the potentiometer. So we have compiled the project. All the files that are required, including the libraries, they are placed on the GitHub, and the link for that GitHub project you can scroll down, and in the comment section you can find that link. Using that link you can get that code, you can see this video, and you can modify them, you can update this game, you can add multiple features, and you can take it as a base point, and you can improve a lot. This will give you a learning experience of this land tiger board.
Okay guys, I want to just show you one thing more. Okay, this is the basically how we are getting data from ADC. This is the function. If you go inside that function, inside this function we call this function. First of all, we'll start the conversion, then we get the value of the conversion from the register, and then we start the conversion. To start the conversion, you set these 2 bits. To stop the conversion, you just set this bit of this specific register. You can read the data sheet from about the details of these registers, and this is the data. Here it is waiting for the conversion, and when the conversion is ready, it reads these registers and returns the value using this. And I also want to show you just a display function. Let's say we are displaying this rectangle. We go to this function, we modify a little bit, we try, you can play with it, we play with its library to generate different patterns. It just basically it takes 2 points on the screen and then keeps drawing line in with different offsets to complete the whole rectangle. This is the LCD set point function. You can go inside that function, and you see it just gives it some cursor value, gets the position, and gives the value to what right there. So it basically just displays a dot. If you see other functions like the rectangles, in the previous video we show you how to draw a circle or filled circle, so you can play with it as you like. I hope this description is clear. If you have any queries, you can give comments on our GitHub project and we can reply you from there. And the other files you see here, you can add them as header files here. Any file you extra want, maybe extra feature inside the game. Okay. That's it from us.
Thanks for watching.